So the record is on.
Hello, everyone, and welcome to the summer webinar series of the Center of Research, Innovation and Design, CRID. A special welcome to our guest speaker, Dr. Fulvio Wirz. Hello, Doctor.
Thank you. Hello, everyone.
Fulvio is an architect and designer, partner at Wirz Architects, and currently working as senior lecturer at the University of East London as program leader of the MA in Architecture and Urbanism. He is also head of Digital Fabrication Lab at the University of East London. He's a former associate at Zaha Hadid Architects, where he has been responsible for the design of more than 40 projects, including cutting-edge buildings and products. Lately, he completed the design of an office in Dubai within the office building designed by late Zaha Hadid. In his presentation today, Dr. Flavio will show us the importance of modularity and geometrical rationalization in complex architectural buildings. Before giving the floor to Dr. Flavio, I would like to ask the attendees if they have any questions for our speaker. Please type them in the Q&A section or send them privately to me. Flavio, welcome again, and the floor is yours.
Thank you very much, Patricia. Thanks for your brilliant introduction. And first of all, thanks to George and the CRID for inviting me today. I'm really pleased to be here with you. I will, move as quick as possible to my presentation because it's a long one. It's going to be, hopefully I'm going to make it in 45 minutes. So I'm going to start sharing my screen. Can you see my screen?
No, not yet.
Okay, there we go.
It's working now.
Okay, so as we said, today's talk is about modularity and geometrical rationalization in complex buildings. Why we care about this? We have definitely, all of you are aware of the fact that in the latest 30 years, the discipline of architecture has gone through an incredible acceleration. And part of this acceleration has been down to the fact that we started exploring digital tools as a device to come up with ideas which brought our concepts closer to nature, not only embedding the forms as you could do even in classic architecture, but really trying to mimic the rules, the set of rules which makes nature intelligent and beautiful. Personally, I had the privilege of witnessing the whole process, as a spectator, but also as a, if you want, main driver and designer at the office of Zaha Hadid Architects, where I've been working since 2005. So I've seen the whole process of acceleration from the early studies, from the beginning where the goal was exploring new forms, since the moment where, the urge of making these forms buildable and rational has became actually much more important focus of the design. Why is that? Because if from one side, we managed to achieve beautiful buildings, incredible milestones in architecture. From other sides, there were also a lot of buildings which never happened and will never be built, like the Abu Dhabi Performing Arts Center here, or the Dubai Opera House, because they simply were too ambitious. Because of a very simple thing. If I go now on Google and I Google construction sites 2020, these are the pictures which I'm gonna get. What I'm trying to tell you is that the building industry is still vastly dominated and based on a modernist paradigm. So what we managed to achieve in architecture in terms of research, in terms of hybridization with other disciplines about use of digital tools, I mean, it has been done in vain if we don't manage to align it to what is the construction process, which is still existing in, which is still dominating the industry. I do believe that this is only a transitional period. That's really important to understand. But nonetheless, for you as students and for any professional out there who's trying to engage with computational design, is trying to push the boundaries of the discipline, if you want to translate this into something which can be, can find an alter ego, can actually be brought to reality, it's really, really important that we think about the dualism between complexity and constructability. In many instances, during my career at Zaha, the idea of rationalizing a building and making it buildable came afterwards. I think this is the moment where we need to think about merging these ideas since the beginning, since the concept. That's why, I mean, I'm going to show you first, you know, an example of a building which has been post-rationalized, and then an example of a building which has been imagined, conceived since the beginning to be smart, to be modular, to achieve complexity through a set of ideas and processes which could make it instantly more buildable. So the first building that I'm presenting is a building which unfortunately wasn't built. It's the headquarters of the Unilever in Jakarta. It's a competition which you know, me and my team managed to win. The idea was to make this headquarters for this very large company, which basically dominates the market of food, and pretty much whatever you find into a grocery store is a Unilever product. And the contest was in the outskirts of Jakarta, in this very luscious, you know, contact with a lot of vegetation, but at the same time with some buildings which were inspired by, you know, the way in Jakarta they crop and they organize the cultivations. And we were asked to make a building which was really trying to integrate the indoor spaces with the outdoor spaces. So we came first with the, you know, the concept comes first from a distribution idea. So I mean, having 4 wings, making sure that different productive department could flexibly be arranged across the building, and they could actually maximize the space, even using agile strategies, which means, you know, not everyone is always sitting at the same desk, but the departments can eventually expand and contract across the building. So that's why there was this idea of 4 wings and a central space. And then there was the idea of bridging only the upper floors of the building to make sure that people could enter into this courtyard, which would become you know, a more intimate inner space for the building. This is the idea of flexibility. So the different wings would allow a department to expand both vertically and horizontally, since the 4 vertical cores could allow also for very direct distribution vertically, not only horizontally. The powerful atrium in the middle allowed to interconnect the building visually. So I mean, there could be control over the production. So there was this very strong idea of powerful atria and visual interconnection. And then there was the idea of splitting the flow of you know, people who are regularly walking into the building, which are indicated with green arrows, from visitors who are normally actually our clients, or who have access to the ground floor of the building, where they normally showcase all products and how they want these products to be you know, normally displayed in a store. So in a way, the ground floor has direct access to the public, whereas there's this gentle slope which leads you to the internal courtyard, which somehow, I mean, gives separates the route of the employees from the route of the guests. So what the problem with this was, at the beginning, as you can see, the concept was based on a slight distortion, almost trying to adapt the building to the site. We issued the competition, and we went through a cost consulting exercise with an external consultant. And the total cost of the building was close to 100 millions. The client came back to us and said, I mean, we like the concept, but the building must be more in the region of 15 million. So what we decided to do is undergoing a very deep rationalization of the building, making sure that the whole plan could be described by continuous arches rather than S-spline. The arches would allow to have a kind of regular panelization for the larger radii, and we could use curved glass only where the curvature was beyond a certain tolerance, so namely in the four corners of the building. At the same time, we decided to give up the idea of having this slight distortion, and we made the building completely symmetric. So, I mean, we could actually repeat and reuse certain parts. We also went, all the way trying to make certain parts of the building completely cylindrical, so out of a straight extrusion, and other parts of the building, like the underside of the bridge, rather than being a completely organic form, it was basically a developable form based on a cone. So it was a conic form. All these things, I mean, led to this more refined scheme in plan, which is very well rationalized. I mean, allows to have a number of panels which can be repeated and made out of flat glazed panels. Just for general information, I mean, the difference between a singly curved glass panel and a doubly curved and a flat panel can be easily twice, if not three times as much the cost. So, I mean, by doing this, I mean, we do believe that the building still retained the original concept. If anything, it looks more balanced and more refined, but we managed to target the budget of the client. So we really almost managed to halve the cost of the building while keeping the same idea. So that's how important is geometric rationalization when you are trying to achieve complex and iconic buildings. But this was done at a second stage. Later on, we got involved into this other project, which is on site, is due to be built at the end of the year. It's not very far. It's in Saudi Arabia. It's not very far from you. It's the Riyadh metro station. It's one of the iconic stations, which is part of a network of transports, which is going to be the first public network of transports in Saudi Arabia. So it's an epochal change in the country. It's set, I mean, this particular station will be the gatehouse to access the KFD, which is the main financial center and district in Riyadh, and also connects the district to the airport. And of course, faces one of the main roads of the leading to the city. So I mean, it's really an important spot because it's going to have a high visibility to everyone who's traveling from the airport to the city. Once again, I mean, the idea was to be inspired by the waves and the dunes of the desert, but even before doing this, the idea was to implement some sort of modularity in the scheme of the building. So we instantly came up with the idea that the the entire envelope of the building could be a self-supported dome to free up as much space as possible inside the building. But rather than going for something completely organic, we instantly decided to have a number of parts which could be repeated, a number of parts which could be locally adapted to pick up the boundary conditions which the building had to adapt to. So the architectural concept starts from the elongated nature of the plot, and from the alignment to the railways, which were predefined by the brief. And then, I mean, we use kind of computational design form finding to spring and relax these lines, creating this bundle of elements which are working like counteracting arches. So, I mean, they're really transferring the loads one to another. So they really work like a structure. In section, this allowed us to maximize the inner space, because the plot initially was defined by the master plan to be a car park space. So by the time they fit the rails and the platforms, there was very little room to have a general space inside. So we had to come up in section with this idea of the dome to cantilever a little bit and gain the additional space, which will allow us to create a quality space around the platforms, which of course were defined by very strict codes and dimensions. So this is the diagram of the roof structure. So in order to stiffen the arches, I mean, we inserted this diagrid, which also acts as the main facade, is where the porosity of the facade and the glazed elements of the facade will be located. And here you can see some structural elements, the diagrid, and the solid roof. Everything in a way is part of a system where all the parts are acting together. This allowed us also to create a cladding system which is completely unitized. So I mean, we used always the same technology, both for the solid parts and the glazed parts. And we designed the structure in such a way that the pace of the structure matches the pace of the panelization. So by reaching this level of integration, we avoided the need of a secondary facade structure. The structure of the facade could be the joints, the brackets could be fixed directly to the primary structure. These are some pictures on site. You can see how the building is absolutely one-to-one coincident to what we've been designing. And here you can see how the unitized element wraps the diagrid, providing outside the cladding with the insulation and the glass, and inside, there's a second cover which becomes the inner finishing of the building. Here you can see, all the layerings, and basically the same concept is applied also to the solid element. The shape of the panel changes, the technology is absolutely the same. So when it comes to constructing this building, you can easily make the same steps. And of course, the fact that the whole building is modular and is symmetric and has some sort of repetition allows to reuse the same molds for a number of panels. So it really, makes sure that you can make the whole, or you can produce the whole panels with a fraction of the cost, because you can repeat and reuse some molds to make the same components. The architectural concepts, I mean, now that we know a little bit about why this building looked like that, it's really important to understand that this concept, another strength of this concept is the fact that it's been designed from inside to the outside. So first we came up with the internal distribution, and then we understood what we needed to wrap it. And all the concepts which I've been describing earlier, they came from the idea that we had to resolve functionally and from a distribution point of view, the building. So the idea, since we were starving with space, was not to have a main structure which would support the different platforms, since it's a multi-story station which is accommodating 3 different lines. So we decided to use these diagonal columns or branching structure and couple it with the vertical circulation. So the structure and the required amount of escalators and the distance between the escalators in order to optimize the people flow had to be absolutely coincident. So I mean, this element takes into account not only the structural loads, but also the distances that you need to, and the amount of escalators that you need to have in order to distribute all the levels of the station. As you can see, I mean, not only there's a very strong synergy between the vertical circulation and the inner structure of the building, but then this becomes the backbone for the design of the facade. The inner design, I mean, is the expression of the structure. There's nothing added besides the need to clad and protect the inner structure. And in a way, there's a very strong integration with the site, although the modularity is the key element. Modularity doesn't mean repetition. It means that you use repetition where it's required, but you use local changes in order to adapt and totally integrate your building to the context. So you can see how the viaducts are integrated and picked by some local gestures, how the viaduct becomes an element which is completely independent. It interacts with the building, but we are not trying to make it part of the building. Also because, I mean, of movements, but the sky bridges, this is a very important feature. I mean, the whole KFD is all distributed at the first floor through these air-conditioned sky bridges, which have been designed by the architect who was in charge of the master plan. So we have to pick this design and integrate it into our fluid design. So we also came up with this kind of fluid shapes, which were, I mean, at some point blending into the triangular shape of the transparent diagrid. So, I mean, we managed to create this sense of integration, mutual integration, rather than an abrupt fracture between the two elements. Even here, so I mean, here literally we managed to create a transition from our flat glazed facade to the faceted element of the building, of the sky bridge. And here are some steps into the construction. This is from a couple of years ago. Then earlier this year, and this is pretty much what we have now. It's almost finished. So in a way, I really believe that this was an excellent example of how you can think about rationalization since the beginning of the design process. So of course, this idea doesn't need to stay with large buildings. It can be applied pretty much to everything in architecture. So I mean, lately, as I set up my own practice, I mean, I had the opportunity to design an interior space within the Opus from CRID Architects. Kind of a funny coincidence, if you like, but totally coincidental. So the idea was to really create a kind of vibrant and interconnected space for this young and successful company. And so the idea was to allow total visual interconnection between the different members of the team, but at the same time also creating some sort of intimacy. So the idea was also to, I mean, the client was keen to have something which was resembling the sand dunes again, and also the warmth of sand. So I mean, we use this specification of wood in order to remind, but at the same time, I mean, we wanted to create something engaging, but staying within a set budget. So whereas, I mean, the building is all, the spaces are all subdivided between enclosed executive offices, which are transparent, but at the same time acoustically insulated. Then the other side of the space is an open space office, where we decided to cluster the different desks using an honeycomb structure rather than the traditional rows, because this will allow more interaction between the different members of the team, while still creating some sort of intimacy. But what really brings everything together are the blades, these wooden blades, which are guiding you throughout the building, and are also organizing the whole space. So now, I mean, what's the why I'm talking about these blades, which, I mean, they might look like a kind of custom design with all pieces one different from another. I mean, compared to the previous project, and it's hard to see the modularity here. But I mean, nonetheless, I mean, if we look at this brief animation, which I'm going to show you, the blades are made out of only 5 different pieces, which are cut from the same piece of wood. And then, I mean, a script has been used in order to populate and make them into kind of sand wave shape. So, I mean, again, it's about achieving simplicity. So complexity through simplicity. So trying to achieve the maximum from a limited amount of parts. So simplifying construction and reducing the amount of wastage in materials. I mean, this definitely allows you also to make complexity more recognizable, because I do believe if we achieve something which is too complex, the amount of complexity which we can generate nowadays with computational design, I mean, it's so powerful that you can easily get something where the real is no longer perceivable from the human eye. So, I mean, you need also to make this, to set some constraints, not only for construction, but also to make sure that your original idea, the rule that underlies your composition is readable, is not overly complicated, that transcends into chaos. Of course, I mean, all this experience is something that I'm also bringing into my teaching experience every day. And of course, as I said, I do believe it's only a transition. I mean, at some point, very closely, we're going to be able to making use of digital fabrication to manufacture pretty much everything we want. But at the moment, as we said, the construction industry is still largely based on a modernist paradigm. So because of this, with our students at the MA Architecture and Urbanism and the MARC at the University of East London, we are working on this framework where we start from components, and then we come up with, we study also the structural nature, the performative nature of the component, the materiality. And then, I mean, this becomes a framework to generate projects where repetition is not actually taken as a constraint, but as a kind of creative tool. Here we can see different expression, I mean, based on different structural principles, the fold, the minimal surface, which, I mean, still can achieve very high level of variation and adaptability but using only, a discrete amount of parts. Also going into the experimentation of minimal shapes, more complex forms, but still based on repetitions and modularity. And all the way going to this very interesting take that one student did last year, where he almost managed to resolve the whole project using only 2 or 3 different forms. So, he could then make and manufacture the molds and, show the final result, which doesn't look like anything repetitive. It still also allows to have a very strong integration between vertical circulation spaces and architectural language, but it is made from a high level of repetition of the parts. And of course, moving this forward into digital fabrication, trying to understand how modularity helps you and fast tracks the manufacturing process, especially when you want to use digital manufacturing, because at the moment, digital manufacturing is not something easy to bring on site. It needs to be prefabricated. So the modularity of it allows you to prefabricate parts and then, ship them on site, and then, reduce the amount of time that the construction site is gonna take. So by doing this, you shift the cost of the complexity by reducing the length of the construction site. Here, another experiment using robotic hot wire fabrication to create the molds, and water-formed concrete sheets to create the final panels. Trying to experiment with eco-sustainable variation of concrete. And then, once again, breaking down more complex forms into repeatable modules. And yeah, this is everything for today, and I hope you enjoyed it. And I'm open to your Q&A.
Thank you. Thank you, Fulvio. That's really interesting. I'll start with some questions that were sent to me from students. I'll start with, out of all the complex projects that you were part of, can you tell us one of the most challenging experiences that you had and how you resolved it?
That's a very good question. The reality is that every project, especially at ZA, has been a huge challenge, because nothing was standardized. I would say definitely a big challenge, very big challenge was trying to reduce the cost of the Unilever headquarters. We thought we couldn't make it. At the end, we really managed to achieve the shell and core for a cost of 1,300 euro per square meter, which was an incredible result for an iconic building. And it took a lot of effort, because the building initially wasn't conceived to have all this level of geometrical refinement and rationalization. But also the metro station. The metro station, the challenge was interfacing all this high level of technical elements and mechanical systems which are coming from transports into the building. Breaking down creating a very clear interface between the inside of the building, which was air conditioned, and the train, which has to pass through the building, so that the train really passes through this platform screen doors, which are and outside, although they're inside the building was like a clay bottle. So it actually, it folds inside, allows the train to pass through the building while staying outdoor, whereas the building is an indoor. So, I mean, there were a lot of different complexity, even in terms of structure. I mean, another thing, for instance, in that building, another huge challenge was the fact that originally we wanted this inner structure, this organic structure, to be cast into GRC panels. So, I mean, the idea was that we would make the GRC panels, of course, prefabricated in a factory. And then, I mean, they would become a permanent formwork. So, I mean, you would have the GRC panels, the rebars, and then you would pour the concrete inside. And once the concrete was cured, basically, the GRC panels would become the final finishing for the building. Unfortunately, we couldn't do that because the structure comes before anything else, and even before the installation of the envelope and the facade of the building. So the result was that if we had a finalized concrete finishing for the internal structure of the building, if anything happened during construction and the panel got broken, it would have been very inconvenient and expensive to fix the panels. So we have to go for a steel structure first. And because, I mean, the steel structure, even if it was hit by anything during construction, I mean, in all honesty, would just stay as a kind of H-beam. And then we have to clad it later on. So, I mean, this changed a little bit the original concepts, but didn't spoil the idea of having this very strong synergy between the inner structure and the envelope of the building. But there are things which happen, and the message that I want to give you, if your concept is strong, and if you manage to set up a very consistent digital process for your design, you are able to absorb these changes. Your final design won't be really affected, won't become weaker. If anything, will become smarter, because you'll manage to adapt your ideas to functional and real problems of the which are given from you are given to you from the construction management.
Yes, but before I continue with the questions, Flavio, if possible, if you could stop sharing the screen so that we can see you. Okay, perfect. I have another question from the Q&A bar. If I were, could be from a student, if I were to create a modular design, how can I make sure it's modularity? It is modularity and not repetition, because you focused on it being modular and not repetitive. And how can I differentiate between them?
Yeah, I mean, in a way, the idea would be, of course, not having always the same element, but studying a set of different parts which are, used to accomplish different tasks. I mean, for instance, if we were to make a residential building, maybe our modularity could try to tackle different scales. I mean, even within the same module, you can have a larger glazed element, a more perforated glazed element, and by the alternation of these different parts, which need to adapt, for instance, to the internal condition of the building, to the external context, you make sure that your building is still modular because it's made out of parts which are within preset sizes, right? And they can interconnect one to another. But at the same time, I mean, these parts can vary. I mean, the amount of modules that you want to use is totally up to you. The reality is that the more the construction industry is going to be able to integrate digital fabrication, the larger the amount of modules we're going to be able to produce, till the moment where where literally difference between something which is modular and something which is just completely freeform is going to be invisible.
Thank you. A question about the software use. I think she means for the digital fabrication of the design.
I mean, at ZA and also now, I mean, we set up a pipeline of different softwares. I mean, it's important to understand that unfortunately, there's no software which does everything at its best. The closest thing to that is Rhino, we all know that, but the reality is that, I mean, for instance, personally, I like to use a software like Maya and subdivision surface to come up with the idea. So manipulate a few vertices and then being able to smooth or to create more tension and more hard surfaces in a very quick way, in a very interactive way. And then moving this to a software which is more precise, like Rhino, where you can maybe further rationalize and you can think into panelization, think into even using Grasshopper to integrate certain environmental condition. And then eventually, I mean, you need to migrate everything to Revit, because that's what the industry wants. I mean, all these big projects, you'll see also on small projects, of course, having a software which allows you to coordinate the different drawings and coordinate the data, the amount of quantities. I mean, both the project in Jakarta and the project in Riyadh, I mean, they could be successfully delivered because we, at any stage through the BIM process, we could know the amount of quantities and how much, a design change would affect the cost of the building. So that's where BIM is really, really important. It's not just about producing sections or plans from a coordinated 3D model, but it's also about coordinating different disciplines, knowing what happens if you change something to the structure. Is the structure still, working well with your architectural finishing, or there's a clash between your beam and your inner finishing, or I don't know, your ducts are not working well with your ceiling design, so you need to coordinate those. Or again, which are the implications in terms of costs. So I mean, making sure that to every part that there's a kind of specification and cost associated. So I mean, you can really control all costs as the project develops, because the project will develop. That's something which we need to take into account. Architectural projects, they're a long process. Things can change. I mean, even with the Max in Rome, I mean, the whole construction took so long for a number of different reasons that meanwhile the local codes changed and the project had to adapt to different seismic codes. So I mean, that's why you see that the Maxi building has some columns which are supporting the cantilevers, because at the beginning, I mean, the code would allow you to do that cantilever, but as the project developed, also codes changed. So architecture is a long process, and that's why you need a very, flexible but powerful process. That's why if your design is based on a process, it can accommodate these changes. And that's also where, digital design and, allows you to, quickly assess what these changes are, what are the implications of these changes in your project. So in a way, these three softwares are those which we've been using the most, interacting between them.
Thank you. In this regard, I wanted to ask you about the simplicity. So you're saying that using different softwares allow you to manipulate different aspects of the project. So while designing to obtain this simplicity, which is simple, complexity using simple designs, so the first thing that you think of is what does digital fabrication allows you to design as simple products, or is it the complex shape that is your main target? Is
Yeah,
it the small simple things that you can do, or is it the complex shape?
yeah, that's a very good question. I mean, we can synthesize these and into basically two macro ways of thinking architecture. The traditional one, which is top down, and the other one, which is bottom up. Of course, when you want to achieve simplicity, you pretty much want to think bottom up. So it means that you first think about the elements, and then you use computational design to apply these different elements to your local conditions. So the complexity emerges from this set of rules which you're applying, as opposed to the early designs from Zaha, which are top down, because we were coming up with a very interesting shape, and then, I mean, we had to post-rationalize it. Well, saying that it was top down is a little bit an understatement, because that complex shape was also coming from a bottom-up design, but it was a kind of more form-finding element. But the outcome of the form-finding then was a very complex shape, which then required a kind of top-down rationalization. Whereas, I mean, if you think like in Riyadh about the way, series of repetition, and you can also literally start from getting interested into a structural system, which can be a portal, it can be a set of arches, and then you see, okay, but my side here is a diagonal. So what if I kind of mirror this arch with a 30-degree angle, which is trying to pick this alignment? What if, I mean, here rather than using a larger span, I use smaller spans because I have smaller rooms, or I need to achieve a higher density of resolution. It's a little bit like working with pixels, really. I mean, we have to think about voxels, and that's the idea. So a 3D pixel, which, and inside this 3D pixel, we fit either a larger element or a kind of a cluster of smaller elements, and then we use the different variation, the different instances according to what happens inside our building, or to what happens when in the way our building interacts with the context. So normally that's where computational design helps you, because you can map these different elements, these different conditions, and then, I mean, the software will automatically place the elements according to your mapping system. That's what I've done, for instance, with the ceiling.
Yeah, I mean, we're showering you with questions, but the students are really interested. All the attendees are interested. I have two questions from the students. I'm gonna ask them. What would be your advice? What would be an advice you would give to the future architects? And another one: the pandemic made us all rethink our majors. How do you see the future for architecture?
The future for architecture. I mean, I think the architect has always been a role which requires you to constantly be in touch with new technologies. I mean, so in order to be a successful architect, you need to be really holistic in the way you approach to the to your studies and to your profession. So, I mean, my advice is, really trying to engage as much as possible with new technologies. I mean, besides digital design, there is digital manufacturing, which definitely can be the next revolution in architecture. There is virtual reality, as we said earlier, which will definitely allows us to speed up our process, and augmented reality, which will allow to speed up the way we assemble different parts. Because, I mean, we're going to be able to see in virtual reality where certain parts needs to be positioned with extreme precision. And then, I mean, going forward, there's also artificial intelligence, which is something that is reshaping the way we can conceive architecture. Some aspects that now are very long processes that an architect needs to do. I mean, they can be picked by artificial intelligence, and somehow we can come up with a very large repertoire of options, which are all responding to our parameters and constraints in a very short amount of time. So all these three big strengths are, I think, all elements that the young architects should try to engage with. And they're still not there. They're up and coming, but the more you try to engage with them, the more you can become a successful architect. And then, I mean, there's also the flip side of it, and which I would say, try to get involved with construction. I mean, just get hired from any contractor and work as a worker, just to see what building architecture means. So you know the constraints from the bottom, and you know the possibilities that you have from the top, and you can merge the two of them. If I could suggest something to myself from the past, as a student, I would say, you know, just to make a little bit of money as you're studying, just go and work as a bricklayer or anything. So learn how to construct things.
Thank you so much. Thank you for the advice that you gave to our students. Thank you for the amazing presentation. That's it for today. Would you like to add something for our
No,
students?
it
Thank you.
was a big pleasure for me to be here. I really hope I could inspire you know, all of you, or some of you maybe. And well, if you want to be in touch, I mean, maybe I can, you know, shall I share my email address
Sure. In the chat box.
in the chat box, or I can just type it here.
At any point, if anyone wants to reach out to you also, they can reach out to us, and then we can link them if they need.
Okay, fine. So,
yeah.
I mean,
yeah.
And yeah, as I said, make sure that you don't stop your studies. You try to engage more even into research, because this is absolutely fundamental. And yeah, I would be really happy to get in touch with any of you, even if you have further questions, even if you want to know more about what we are doing at the MA Architecture and Urbanism. I mean, it'd be lovely. You know, we can set up twinnings. We can try to do something together. That would be absolutely brilliant.
So
thank you
so much for accepting and being here and give us this very interesting presentation, Fulvio. So I thank you so much from my side.
Yeah, that's been my pleasure, absolutely. And it was great to know, you know, your about your center and what you're doing. It's really, really interesting.
Thank you.
Thanks.
Bye, everyone.
Goodbye. Thank
Bye.
you.